So coming back to this. Okay, so all that was prep for this guy. Can anyone identify why what I just did won't work here? Two reasons. They're both sine, and one has an angle of 2t and the other one has an angle of t. Yes? They're not going to work together the way I want them to. So to do part B, we're doing part B. What can I do first to help with the fact that they both talk about different angles? What do you mean separate 2t?
That's 2 sine cosine.
Yeah, sine of 2t equals
2 sine cosine.
2 sine t
2
cosine t. That's an identity you all know. Okay. So again, eternally, I don't care what problem it is I'm doing, the problem I'm doing doesn't mean anything. What made me do what I did is everything. So why did I just decide to use this fact? Because this angle and this angle are different. If they're the same, they could work together, right? So now I can rewrite sine of 2t here as 2. Just don't look at the minors. Sine t cosine t. Now, part of this kicks ass. Does anyone know what sine t is? Look up here. This is everything you know for this problem. This is your whole universe is right up here.
Oh, you can find sine t by moving it over.
So if I divide by 4, do I know what sine t is? So I can put that here, yes?
Yeah.
What does this need from me? The cost of this, right? The cosine t? Let's stop for a minute. So when you're given any system of equations, in this case it's a parametric system, there are two things I know. I know x is negative 5 sine 2t, so we rewrote that. I know y is 4 sine t. I could use that shit. That is information I know. I could use it. And why is it good that I know? Because part of what I need to figure out is sine t. So to get what x is, I have to know what sine t is, and I do. Check. I have to know what cosine t is. Do I know what cosine t is yet?
Can you find t by just doing the inverse sine?
Screw that shit. Sine is y over 4. Y sucks for me, I'm sorry. What side's y?
Left up.
Good, the y. And what side's 4? You were kidding. So how do we get the cosine? What do I need?
You need
X over 4,
Why would it be x over 4?
because that's what cosine was.
Oh, do I know this side yet? I don't know the side is x.
No.
In fact, I know for sure it's not x.
y plus x, y squared plus x squared.
I have a right triangle. I have two sides. I can get the third side, yes?
Negative 10y over 4.
No stop sign. Okay. So everybody agree with me that I know sine t is y over 4?
Yep.
Okay.
4 minus y.
Stop. If I know sine t is y over 4, I can draw this triangle, yes? Why do I need to do that? Because I need you guys to be really with... So pretty cool with the fact that I did this. So I notice these angles aren't the same, right? If they were the same, these two would work with each other. So the very first thing I want to do is replace sine 2t with something that has t as the angle. So now t is the angle. Sine t is y over 4, that kicks ass. I could put that right here. If I just knew what cosine t was, I'd be just about there, right? I'm missing the side, don't say a word. Figure out what that side is. If I knew that side, I would know the cosine, yes? So if you just give it a name, don't call it x because x already exists. We're just gonna call it a. What can you set up? What equation?
X squared plus y squared.
I don't see x.
Let's go like the square
Y
root.
squared plus a squared equals
4 squared.
16. Trying to solve for a, right?
16 plus y squared
Minus,
minus y squared.
and then
Equals
square root. We kind of always assume these are positive just because it's a physical triangle. So now I know that's the square root of 16 minus y squared. What's the cosine of this angle?
four minus y.
Sine.
Okay.
We do.
Quick side note, everybody. Is the square root of, let's see, what's a good example? Yeah. Is the square root of 4 equal to 1? Is it 9? Let's see, what's a better example? I like this example better. Is the square root of 13 equal to 5? Is that true?
No.
Isn't 13 4 plus 9? What's the square root of 4?
2,
What's the square root of 9?
3.
But we know this isn't true, yes? So a square root does not distribute. Yes, square roots are based on what operation? Multiplication. So they're not going to distribute across addition. So the square root of 16 minus y squared is not 4 minus y. You can't square root each piece because this doesn't distribute. Okay.
Right.
It's just this. So what's the cosine?
It's radical.
Yeah, it's the x side
Radical 16 minus y squared.
over,
Over right.
no like, over 4. Because that's the hypotenuse. Does this equation have any t's in it?
No.
Nope. So did I kill the t?
Yeah.
Yes. I will say this. That's one of the harder questions on this practice test. It is. It's one of the harder questions. I understand. So if that's one of the few you had trouble with, you're doing pretty good. Yeah.
This might be stupid. Where'd you get the 4?
This 4?
No.
This 4.
Yeah.
So I got it from here. So what's the cosine of this? Won't it be the x side over the hypotenuse?
Oh,
Yep,
yeah.
That's all. Yeah.
Alright.
Yeah.
For the points that we're plotting, I chose like pi over 4. I didn't want to just do pi over 2.
Yeah, that's what I would do. In fact, let's do that together because I think I left that off the answer key. So just didn't have time. So let's do number 4A together. All right, so let's make a T, X, Y table.
Can we do a 45 degrees?
Yeah, we'll do, yeah, sounds good. And I told you that T goes from 0 to 2 pi. So obviously we'll start with 0. What's negative 5 times sine of 0? What's sine of 0? What's the sine of 0? I like it, somebody's giving me a little symbol. Yeah, sine of 0 is 0. So incredibly enough, the sine of 0 is 0. Okay. So it starts at the origin, neato. Philip's got a good idea. Let's put a pi over 4 in there.
3 pi over 4.
Huh?
3 pi over 4.
Not yet. Let's do pi over 4 now. If you need to, you can write down. Yeah? Stop looking at that. So what do I get when I put a 3 pi over 4 and what happens here? What happens?
And you get a value of
What's the sine of 3 pi over 2?
1 negative. Or no.
Negative 1?
Yeah, because 3 pi over 2 is here, right? This be negative 1. So don't I get negative 5 times negative 1? Which is? It's crazy. Good Lord, Jeff.
That's why.
Oh. I had your thing in my head.
No, you didn't plug in pi over 4, you plugged in 3 pi over 4.
You told me to plug 3 pi over 4 and I couldn't get it out of my head. Let's try this again. So if I plug pi over 4 in, negative 5 sine twice pi over 4, negative 5 sine of pi over 2. Sine of pi over 2 is 1 times negative 5. Negative 5.
I have a question.
Yeah.
You got like negative 5 sine of 2t, and you got 4 sine of t. Could you use like a half angle identity? Figure that?
I have no reason to. I would definitely not do that. There's no reason to. So each equation, the x equation, the y equation, do their own things. I'm just gonna leave them alone. Part B, where I have to kill the t, where I have to get rid of the t, then I gotta do some shit. On this one, I'm just getting numbers. I'm just gonna leave them alone. It would so suck to make that negative 5 times 2 times sine t cosine t, because now I have 2 trig functions to evaluate every time. Screw that. I just want to keep it 1 trig function. All I care about on this one is just the numbers, right? I just got to make the points. And dear God, everybody, please, dear God, you're just plugging numbers in, and you're the one picking the numbers to plug in. So I'm not going to plug in like pi over 5, because I don't know that angle. I'm going to plug stuff like pi over 4, pi over 2. So what do I get here? What's the sine of pi over 4?
No, it's not. It's rad 2 over 2.
Square root of 2.
Yeah, rad 2 over 2. So I get 4 times rad 2 over 2. I get 2 rad 2. And a really good thing to know is rad 2 is about 1.4. Now, you could just plug this in the calculator, to be honest, but so you'll get about 2.8. Twice 1.4 is about 2.8. I just need approximations because we're going to graph this thing by hand. So all we're doing is plugging numbers in. Yeah. So what's a good thing to plug in next?
3 pi over 4.
No. Pi over 2. We'll get there.
And then the next one will be pi.
No, then the next one will be, yeah, because we've established we're going by pi over 4, yeah? Okay. Can you guys do this in your head? What's twice pi over 2? Pi. What's sine of pi? 0. And of course, what's sine of pi over 2? 1 times 4 is 4. All right, Philip, you're good. Let me have other people. Okay. I got you. So then 3 pi over 4. So I'm just creating points so for that I can graph in a minute, right? So right, 3 pi over 4 we already did a little early. It's still here. I could have just left it here. That's where the sign comes out to be negative 1 times negative 5 is positive 5. What's sine of 3 pi over 4? What quadrant am I in? So I'm not sure. When I say sine of 3 pi over 4, what should be happening in your head is you know you're here. What do you know sine is? Sine negative or positive? Positive. Sine is y. Is everybody with me? So this is why I made you draw a little reference angle work and so forth before, because one of the first things you should do for yourself is, you could even draw it down if you need to. What quadrant am I in? Why is that important? Because it tells me if it's negative or positive.
Yeah.
So I know I'm positive, and any pi over 4
Rad
has
2
a
over 2.
rad 2 over 2. So it'll be this again, yes?
It'll be a positive, right?
Yep, it'll be a 2.8. And why does this make sense? Look, didn't sine grow, and now it's starting to shrink? That's exactly what sine does. So sine's doing what it's supposed to do. Why is this one a little weird? Because it's sine of twice t, so it's doing its own thing. It's going through stuff quicker. So now what do you think I'm going to plug in? Pi. And here's where we can start to be smart about this. What do you think is going to happen here? You see I'm going to put pi, 5 pi over 4,
It's gonna be a 0.
3 pi over 2.
Negative 5,
Yeah, it's going to be a 0,
negative 5,
negative 5,
0,
0.
5,
Let's see, 7 pi over 4, 5, and then 2 pi.
maybe another 0.
Okay. Do you guys see, you get to a point where you don't have to do the work anymore, you see the pattern that's happening? What's sine of pi? So now I'm up here, I'm going to plug a pi in for y.
0, wait, 1.
Yeah. No, sine of pi is 0. Now what quadrant am I in? Third quadrant. So I'm going to get the exact same numbers, they're just all going to be
Negative.
negative now. So you don't have to do the work for every single thing. You can just realize what the pattern is. So now I'm going to give the exact same numbers I did before, they're just going to be negative. Bam! So I only had to do half the work to get that whole table filled in. And now you just plot those points. So let me get a better graph here. Let's see if I can make this work. Yes. So it looks like I can use a negative 5 to 5, negative 5. I don't have anything bigger than 5 or negative 5 yet. So I don't have to make a special scale for this. I can just use negative 5 to 5, so forth. So then I just start plotting. 0, 0, negative 5, 2.8. So we've got to connect these. It shouldn't be a really straight line, but that's okay. 0, 4. 5, 2.8. This is nice. 5,
Oh,
2.8.
it's gonna make that little lotus thing.
Huh? Yeah. Jeff, you're looking at the monitor. It's okay. 0, 0. So come back here. So there's Stewie. Set her up there. Negative 5, negative 2.8. So negative 5, negative 2.8. So can you guys see where this is headed? Negative 5, negative 2.8, 0, negative 4, 5, negative 2.8, and then 0, 0. So it just goes through here, 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 then back. And hopefully maybe some of you guys drew a little bit better than me, but. Okay, and remember, you can check your work in the calculator. I showed you how to graph the parametric stuff. I showed you how to make a parametric table, right? In fact, now that we've gone through that, just to remind you guys, do you guys remember how to put this in the calculator, this system of equations? Well, I have to make sure I'm in first. Parametric. So we'll go to mode, parametric. If you need to borrow a calculator, I got some, but if you want to just watch this, okay. Then when I hit y equals, I got my parametric options. So I can put in there negative 5 sine 2t. I can put there 4 sine t. How do I make sure it does what I want it to do for t?
You go to your window.
Window. So 0 to 2 pi, it's already there. Pi is 3.14, 2 pi is 6.28, blah, blah, blah. So if I graph this right now, well, let's see here we go. Oh, poor little dude. What's the other thing I have to be careful about?
Your window?
I mean, radius.
Oh, radius.
That'd be in radians. There we go. That's nice. And again, just remind you, go to your table. Now let me make it this. Here's what's neat. You ready? What was our step? How much did we step by each time?
pi/4.
So what I'm gonna do, I'm gonna start at 0. Jeff, you can try it again, buddy. Start at 0. Step by pi divided by 4. Let's see if it's able to do this. And set this to auto. No, Jeff. Good Lord, dude. Go try this again. Table set. 0. Pi divided by 4. Set this to auto. Go to my table. Does those look familiar? It could have little resolution problems. Does anyone remember what that means? 1e negative 12?
1
1
times
times
10
10
raised
to
to a
the
negative
negative
12?
So this is it trying to say 0, but it's going to have some resolution problems, right? It's a piece of technology. It doesn't know shit. It just does shit. And sometimes that shit doesn't really get to the answer perfectly. So it's like, I don't know. But we know it's trying to say 0. As you can see how it's exactly the same points we got. Okay, so you have ways to check yourself before you wreck yourself. Okay. So when I ask you to graph a system of parametric equations, you're just plugging points in. I'm going to always give you what t does. So you know where to start, you know where to end. Okay. Huh?
Would that just be finding x and then finding y?
What's that? What do you mean?
5.
Oh, for 5.
Or I already found it.
So there's problems in the homework just like 5. I want 2 possible parametric equations that lead to this. So what's parametric equations mean? That means I have x as a function of t and y as a function of t. What is the easiest frickin' way to make a set of parametric equations? Make one of those just equal to t. Which letter in this problem would it be easier to make equal to t? So then I can figure out the other letter really easy. No. So you had a 50-50 shot to it. If I make y t, what's x?
It's
Make y
t squared minus
Yes.
3t.
So the easiest answer to this is to let y be t, and then x is just t squared minus 3t. Good Lord, Jeff. Okay. That is the easiest answer. Just if I made x equal to t, I'd have to solve for y. I don't want to solve y squared minus 3y equals t for y. That sucks. I'd have to use a weird ass
Wouldn't that be written?
quadratic formula. Huh?
Wouldn't that be written the opposite way?
What do you mean?
T for y?
Say again?
Wouldn't that be written yt equals t squared minus 3t? If you're plugging in t for y.
Of course not. What is equal to y squared minus 3y? X is equal to y squared minus 3y. So if I make y t, x is equal to t squared minus 3t. If I replace y with t, I get t squared minus 3t
Oh yeah,
equals
that's
x.
the point there, number that you're plugging in.
Now, how do I make another one? I want a different set of parametric equations. How do I do that? We've already identified that y is a good one to start with, because whatever I make y equal, I just plug it in to figure out what x is, yes?
Or you can add a number to both sides and backwards.
Somebody give me any function. Give me a function. Any function. Anything. Any function. More than that. We already have y of t equals t. So I want a more interesting function of t. Not that much, just anything.
Y equals x squared plus 2.
Okay. So if I let y of t equal t squared plus 2, what is x of t equal to? Remind me, what is x equal to in this problem? What is x equal to? In this problem, what is x? Y squared minus 3y. What did we just say y was? We just said y is t squared plus 2. So aren't I just going to rewrite this damn thing? What do I put in place of y?
T squared minus 3t?
What happened? No. What did we just say y was? What did we just say y was? T squared plus 2. So what am I going to put everywhere I see a y?
T squared plus 2.
Okay. Is that the only other answer? Obviously not, because Brooke just gave me a function. You could have given me any damn function. So another possibility. Another possibility for this would be y of t equals sine. If y is sine, what is x? What is y? Sine t. Y is sine t, yes. If I say y is sine t,
The sine of
X is cosine t.
okay.
sine of x, y squared, sine times
Yeah.
y squared. Right?
Stop.
So,
Okay, let me write it like this. Everybody agree from this problem that x is y squared minus 3y? Does everybody agree?
yeah.
Okay. If I say y is sine of t, what is x? Sine squared t?
Sine t squared minus 3 sine t.
Yeah, okay. Yeah. If I told you that y is 2, how would you figure out what x is? Plug it in, yeah. So you get to pick any function you want to for one of these guys. How do I tell which function I want to use? I want to use the function that's an input for the other one. Because now if I say y is anything, I can plug it in and I'll know what x is automatically. Because x equals that stuff. So what else could you make y equal to?
Marmalade.
Marmalade of t. So if y is the function marmalade of t, what is x?
It's marmalade squared minus 3 marmalade.
Yes, okay. What is the marmalade function, you ask? Mike can show us. Well, hell, there's a freaking function called sin, so why they can't be a freaking function called marmalade? Why not? So just to give you so could I call it natural log of t? Hell yeah! And then what would x be? Natural log of t squared minus 3 times?
Natural log of t.
Okay, now maybe we're getting it. Now, I needed everybody to be at least there with me before I could keep going. If I choose y to be sine, what's the biggest y could be then? If y is sine of t, what is the biggest output I could have for y? 1. What's the smallest?
0.
-1. Yes? So the choice I make will restrict what the graph ends up looking like. So this is really freaking cool. I want to show you this shit. So does everybody know what that would look like? Okay, y equals x squared looks like what? Looks better than that, Jeff. Y equals x squared looks like what? Help me out. Just draw. Thank you. Just make me feel better. Okay, thank you. All right. What is x equal to y squared? I believe I've told you this before. It should make sense. Y equals x squared. X equals y squared. Yeah. Still a parabola. Still has the same idea. It's just that the input changes to y. So now it kind of opens this way. Or actually, I'm sorry. This would be this way for a positive.
Yeah.
This should look like this shape. It's just been moved around. You guys with me? This is like shifted a little bit. Okay, so watch this. If I put in here, let's put our first one in here. The really silly one. The first one we did was this one. If I make y t, and I make x t squared minus 3t. And I'm going to let my, so watch this. I'm going to let t go crazy. I'm going to let it go from, not too crazy, -20 up to 20. I get what I expect, yes? Is that a sideways parabola? Let me make my window a little better. Oh, now I've screwed things up, Jeff. Good job. -20 to 20. Okay. Chua! Okay. Everybody with me? Okay. If I do the other one we just did, the sine, if I let y equal sine t, you could do it, Jeff. Where is it? There it is, buddy. That would mean x is What did I, oh yeah, figure something out. Sine of t squared. What was it, minus 3? Sine of t, I believe, is what it was. Yeah, okay. You ready? Let's see what this does. Did it give me the whole parabola? No, because both of these are restricted. The biggest this could be is 1, the biggest this could be 1. The smallest this could be is -1, the smallest this could be is negative. So there's no way it could ever give me the entire picture. So there are an infinite number of ways to take any freaking y equals a function of x, anything with y and x in it, and convert it to parametric. You can make either one any function you want to, and then the other one becomes whatever the shit it does, right? We just plug it in. Are you with me? The choices I make have ramifications. I'm not going to get the whole picture if I choose a function that has a limited range. Does that make sense? I'm never going to get the whole picture, but there could be a reason why that's a good choice. I don't know. It's just good to have the flexibility, but you have to understand the choice you make limits things possibly, maybe.
It could be a good choice, because maybe you need to limit it in order for it to pass the horizontal line.
Yeah, exactly. There's all kinds of considerations for why I would want to choose one rather than the other one. Okay. So there are problems in the homework that are kind of like that. They're a little bit more simple, but it's like the base level of it. But in general, you have an infinite number of things you can make. Okay. So what I'm going to ask you on the test is, I'm going to ask you to graph something, of course. Right? So you got to make a TXY table. I'm going to ask you to eliminate the parameter. I'm going to give you one that's simpler than this one, because this one is a little, and again, I like to push you a little bit in the practice test. It's kind of like if anybody ever played basketball. If you practice with a slightly larger basketball, you're that much better when you play with a normal size basketball. So my practice tests are always, I try to make them a little bit harder than the actual test, with that same thought in mind. I could just end up freaking everybody out, but too bad. I don't think, I think I did. I can't remember if I finished this one on the answer key. I did. Somehow I slammed it all in there. That's crazy. Okay. Anything else you want to focus on? How do you guys feel about this kind of problem? You guys, where you should be with this, which is you should just love the hell out of this kind of problem.
Oh, that's easy.
Yeah, this problem's so nice, yes? Is everybody cool with the other representation?
Yeah, it could be like a negative of it.
Sure, I could, so for example,
The opposite.
what have I done? There it is. How do I plot 2 5 pi over 4? Which way do I face? I look at 5 pi over 4,
Yeah,
and then I just walk out.
two
Two.
little rings.
Now, what's another representation then? What if I face pi over 4? If I look at pi over
Being
4,
like
which
negative two.
I would walk back to, correct?
Yeah.
So I could always figure out what's the other representation. If I walk backwards, that means I must be facing the other way. I must be looking at pi over 4. That would lead me to the same point that does. That's what the other representation means. So once you plot it, it's relatively easy to figure out another way to represent it. Okay, I like it. You would, Jeff.
So for C, we go backwards.
So where am I at? Negative 4 pi over 3.
We go to pi over 4.
Huh?
Wait. 4 pi over 3.
If I go back 4 pi over 3, where do I end up? If I go back pi, where do I end up? Here, yes? How much more than pi is 4 pi over 3? If I have,
It's one more third of a pi.
what's 4/3 is a mixed number?
1/3.
1 and 1/3. So isn't 4/3 1/3 of a pi more? So I'm going to go pi over 3 more. So where do I end up if I go pi over 3 more?
Pi over 6.
No,
2 pi over 3.
2 pi over 3. So I have to face negative 4 pi over 3, and then I walk forward 5. So there's an automatic, really easy way to rename this, yes? And by the way, dear God, whenever you have this kind of problem, please, dear God, label the points. Holy shit. Right? Please, dear God, label your points. What's the easiest way to rename this, considering where we're actually facing?
-5.
No.
Or 5.
2 pi over 3, because that's where I'm actually really facing, yeah. Right. So basically, the two main ways to redo a polar point is with a negative r or a negative angle, like the opposite angle, right? That's kind of like the two main ways to do a different way to represent the same point. Okay.
What about 8 and 7?
Sure. So what do you have to know? What can you just kind of dump at me all the stuff you're supposed to know? What's x squared plus y squared for polar?
R squared.
R squared. What's tangent theta?
Y over x.
Yeah, that we've known forever. What is x in terms of r and theta? Yeah. Thankfully, you got a teacher told you about x likes cosine, y likes sine. So y is r sine theta. Of course, I can't draw the letter y, but you know. So if I give you, is this point? I have to tell you really. It's in rectangular, so this is x, y at the moment. How do I figure out what r is? I know x and y.
X squared plus y
Yeah,
squared
I use this
equals
guy.
R squared.
Just plug and chug. How do I figure out what theta is?
Be like arc sine,
I'm going to have to do arc
arc tan.
tangent, yes. Now that's on the answer key, but I mean, we can do them if you want to. Look at part B real quick. I could just blindly replace all the x's with r cosine theta and all the y's with r sine. That's insane. What is y over x? Tangent theta. Can you make x squared plus y squared show up?
What now?
You can do one thing to this and make x squared plus y squared show up. What can you do?
Move the y over.
Add the y squared over. If you see x squares and y squares, you say, wait, can I get those together? Because that's beautiful. I can just make it r squared. Both of them, r squared. That's awesome. Right? So that's the first thing I would do is I would add y squared over, then that just becomes r squared. Y over x is,
9.
no, y over x is
Sine.
tangent. And what is 9x? What's x? R cosine theta. Sure. How do you know you're done when you don't have any x's or y's left? You have nothing but r's and thetas. So this is just the reverse, right? This is actually nicer, to be honest, because how do we get x just very directly? If I have r theta, I just plug them in, check them out. If I give you an angle, you know I don't want to see decimals. You with me? 5 pi over 6, we know everything about that. I don't want to see decimal answers. What about 8b? Why does that kind of suck?
The 5 is there.
No, the 5's fine. Poor little 5. There's only a cosine here. What do you wish was in front of the cosine? R. So how do I make, in fact, what do you wish was in front of the sine? R. Because if it was R cosine, wouldn't that just be X? So how do I make an R show up in front of those? Do I just write in and say, you meant this, Jeff, I think? Yeah, multiply both sides by R. What kicks ass over here when you do that?
Equals r cosine theta.
Minus 5 r sine theta, and then r squared you know, r cosine theta you know, r sine theta you know. Done. So, like so much of mathematics, you have to know the basic memorization stuff. That has to be there. Then it's all about what are you looking for and what are you allowed to do. That sums up almost all of mathematics. Basic memorization shit. What are you looking for? What are you allowed to do? So what am I looking for with this stuff? Well, I'm looking for x squared plus y squared. I'm looking for r squared. I'm looking for r cosine theta, right? I'm looking for y over x. Why am I looking for those things? Because they're the stuff that I have to memorize. And I can't remember if I told you, I'm pretty sure I told you guys this, but be careful. Be very careful. Remember that thing I told you about the memory dump? When you memory dump that shit on the test. Because otherwise, I don't know, whatever piece of paper you dump it on, I don't know if it was there before or after.
Can you give us an extra sheet of paper for us to test?
Huh?
Well,
No, it's too bad. No, you do what you can. It's too bad. You don't have to memory dump. You can if you want to, with the materials I give you. Anything else on? We could do more examples of any of these. How about these guys? Which one of these would you use law of sines on? Yeah, why can you use law of sines on this one?
you have an angle and a like.
Yeah, I have an angle and its side. When you use law of sines, what do you have to be careful about? Could be a second triangle. That's the appropriate phase. I like that. That's when you did that. Second triangle. Okay, so real quick, let's do this. You everybody's cool with this is the law of sines? Okay, help me set it up. What's the complete ratio can make? Sine of 39 degrees to 5.1 equals. Yeah, I don't know a damn thing about C, so I'm going to use B. Yeah? Oh, and B is 6, so that's easy enough. How do I solve for angle B?
6 times sine 39.
Yeah, multiply the 6 up. And then I take the,
You divide by.
no, how do I kill the sine?
You kill the sine with the arctangent?
Arctangent would kill a tangent.
Oh, arcsine.
Yeah.
Check that, you know.
So you can't use silver bullets or anything. You
I
have to use
know what I
arcsine.
want to do. I could write it, I just.
No, I'm with you, Mike. I know.
Okay.
So, yeah?
Would you just get the radians of all that and then just do the inverse sine? It would be the same thing.
Get the what now?
It would be the same answer, right? If we divided that out first in the calculator, like 6 times.
As long as you don't round at all. So make sure when you type it in, you go forever.
Yeah.
Okay, yeah, if you want to type in forever. Yeah, I don't know if you're going to have enough time. So I need you to understand. If you get a number for this,
Yeah.
you've rounded.
And then you just put.
When you do arcsine of a rounded number, you're going to get the wrong answer, okay? So you guys should be at a point where you're able to handle just plugging a bunch of shit in. So inverse sine, and I'm just going to plug all the stuff in.
Okay.
Let the calculator worry about all the decimals, right? Didn't cost enough money. Here, so what do you guys get? Anybody trying that out before I hit enter? I want to show you, when you do law of sines, I want to show you exactly what you do to tell if there's a second triangle. Yes? I told you already, but I'm going to tell you again. So help me out. What do you guys get? Is everybody cool with the first step there? I have a complete ratio I can make. I have information about another letter, so I use that.
You want it in degrees.
Huh?
You want it in degrees.
Degrees, yeah. So let me make sure I'm in degrees. So what do you guys get? Anybody?
47.76.
Yeah. So that is what I'm going to call B1. So here's where it's okay to start rounding. At least we're not rounding too early. What could B2 be then?
180 minus 47.
Yes. So B2 could be,
Yeah, that's 39.
yeah. I want to make sure everybody's with me. You guys all with me? So you find an angle. When you find an angle, you do 180 minus that. That's equivalent to pulling this side over. So either it's this angle or it's that angle. That's what that's just swinging that side over. That's what I'm doing right here. Does that work with that angle? Does it leave enough room for a third angle? 132 plus 39, is that more than 180?
Nope.
I don't even care what it is right now. It's less than 180, correct? So there's room for a third angle. Too bad there's a second triangle. At this point, you're hoping there's no second triangle, because then it's less work, yes?
Yeah.
But you could be pretty sure that you're going to get a second triangle on the test. Just, know how to check for it. But know you're going to get it, if that makes sense. So then I would just finish this out, and then I would worry about the second triangle after that, right? So let me give you the answer key. So we did number 5, 8 together. I didn't put that on the key.
Before
Huh?
before A, T.
Four, yeah.
The hardest one of the test is before B.
5A? There's
Four.
only one 5.
4A I did.
Oh, 4A.
4A.
Okay.
Yes. Tomorrow, yes. Wettedness this day. Yes, today is wettedness this day. Oh, I have one left. Yay. Yeah, yes. So, what am I going to do in part B here if you don't look at the key? Why can't I not use signs here? Law of signs.
We have three different.
Yeah, I don't have any complete ratio I can make. That automatically means for us that law of cosines should work. Can somebody tell me what the law of cosine says without looking at anything? I'll get it started.
A
C squared.
squared equals B squared plus C squared.
Oh, okay, so
Minus
what was,
2AB.
Mike, stop. What'd you say over here?
I said C squared.
Okay, C squared equals B squared plus
A
A
squared
squared.
minus 2AB cosine C.
Yes. So these go together. These go together. Yeah. So there's Pythagorean theorem. Right. So if I were you, I would remember this, because it's Pythagorean theorem, and all you got to memorize then is this. You guys with me? Then if you had to figure out A squared, I would just replace A and C. Like that, right? The form of the idea stays the same. I don't have to memorize 3 things. I memorize 1 thing, and then switch the letters as I need to.
We have work to just remember that the outsides are the same letter.
Yeah, exactly. That's what I just said. So the outside letters go together, and the inside letters go together. Yes.
The hardest one is 4B, I think. Oh, we already went over.
Yeah, I told you guys that was a pretty good one. Yeah, that's a pretty good one. The one I'm gonna give you won't be as crazy.
Also, 2 is, we went over that yesterday, but 2 is also a little bit.
2 is nifty, yeah.
It's kind of funky.
But the thing with 2 is it just reuses the same stuff. R squared is x squared plus y squared. We know.
How do you,
Theta is an arctangent of y over x. We've known that, yeah.
So my question is, how do you know when to add 180 when it's not in, because when the quadrant is, wait a second. Because why would, because
Look, stop. What quadrant is that in? Positive on the on the real axis. Negative on the
y-axis.
imaginary axis, right?
Imaginary.
So what quadrant is that? So let me see, from your perspective, positive on the real
That's
and negative.
4.
Fourth quadrant. So whatever angle I get better be in the fourth quadrant, or else it doesn't represent that point. That point is in the fourth quadrant, correct?
I'm referring to B because.
Sure, I mean, I don't care, whichever
that
problem.
one we didn't have to add.
Alright, so again, what quadrant is this in?
Third.
Back, down, third quadrant. So when you do when you do the inverse tangent, you get an angle that is in the first quadrant.
I see.
Okay, so that's a reference angle I got. So then I add 180 to get it in the third quadrant. Yeah.
Because.
The period of tangent is
Okay.
pi. So I just add, or 180. So I add 180.
Yeah, pi. Yeah.
Yep.
Because you're using tangent on the triangle.
So definitely you guys should all be able to sink your teeth into these kind of problems. These are just brute force, sink your teeth. No real concept that as much as some of the other stuff we've done. It's just pick a letter, kill it twice.
On the homework, there was one question that was just like, I tried to kill every letter. I got a giant fraction for each one. I'm just like, but all the other ones I got numbers.
Yeah, I can't remember. There could be some problems with the fraction. I mean, that could happen.
No, I mean, it was an insane fraction. It was
Yeah, don't do that.
100 and something over 100 and something.
Yeah. So let me see. I think the consensus is this one is definitely freaky because this one we didn't like do a ton with, but there's not a ton to do with this. And I don't. So just remind yourself, the real one is basically x. The imaginary one is basically y. Then r squared is x plus y squared. Tangent theta is y over x. All that stuff is the same shit. Why does it make sense? Because it's polar. It's still polar coordinates. It just happens to be real and imaginary. Who cares? It's still polar coordinates. So of course it carries over all the same stuff from polar.
Reverse polar notation.
Let's see. These kind of problems, I don't know, just, So look, see how I'm trying to be nice to myself? I figured out B. Then I check to see if B2 exists, and it does. So then here's the first triangle, here's the second triangle. And I just did all the same work. If I'm nice to myself, it's nowhere near as bad as it seems like it could be. And you're all like, sure, math boy. Okay.
So what kind of questions should we expect with that question?
Whatever I feel like at the moment.
Alright.
Yeah. I can make them whatever the hell I want them to be.
Alright.
I can make them non-mathematical problems, right? So normally I like either the bonus is gonna be something where it's gonna involve a lot of weird shit, or it's gonna be something where if you understand it, it's one thing, right?
Alright.
That's kind of the categories my bonus normally falls into. Huh?
No word problems.
Huh?
No word problems.
You want
We have
nothing but word problems
word
for the
problems.
bonus? You want okay, nothing but word problems.
There was one on the homework, I figured it out, I just figured out, three numbers equal 147. The first number
Oh, yeah, yeah,
is half
yeah.
of the second number, and the second number is half of the third number. I just put that as 1/4 x. plus
It's just a
1/2
bunch of
x.
substitution. Yeah.
I'll take one of those. But
There's the
some of them are a little bit weird, so.
If it's a bonus, it's gotta be weird. Alright guys, if anybody has more questions, there's still another 5 minutes, but otherwise, y'all are free to go, obviously. I have office hours still, you can stop by. Tutors are up there. Yep. Yeah, we did that problem. Yeah. sucks to do it by hand, but if you do this, you just multiply the arcs and then add the angles. Yes. What's up? Sorry? You want the answer key?
Oh, yeah.